Okay, we are gonna go over 8.5. I am not gonna go over the quiz and we can do the quiz together, or after we go through the homework, if you want, if you're feeling good, you can go check out the quiz. You can even answer it, and before you submit it, we can go over it together or something like that. It's just hard for me to switch back and forth, is the only reason. And doing the quiz together won't take us very long. Okay, so for the homework of 8.5, I'm on question 1. So before we do question 1, these 2 boxes are the 2 big points of this section. And these are in your notes. I just copied and pasted them so they're together. Basically, what both of these are saying, if you have an exponential, so if I have like 2 to the x, and then I have this equal to 2 to the 2x plus 1 or something. If I have these 2 base numbers that are the same, so in this case they both equal 2, then I can just set their exponentials to each other. So all it's saying is that if these bases are the same, I know this has to be equal to that. And then I would solve for x to solve the problem. The same goes for log. If I have logs with the same base number, so I'm going to use 2 again. Let's say this is x equals log 2. We'll use the same basic idea, 2x plus 1. So because these both have log base 2, I know that these 2 things need to be equal to each other. So I just set it equal, x equal to 2x plus 1 to solve for it. Okay? So that's the big point in this section. So for question 1, we have 3n plus 8 equals 3, 6n minus 9. And these 2 bases are the same. They're both 3's, so I can just set the powers equal to each other, and then I'll just solve for n. So now I've got this set up, so now I'm just going to solve like I normally would. So I'm going to subtract n, and at the same time I'm going to add 9 over. If I'm going too fast, just pause it. So this is 17 equals, is that right? Yes, equals 5n. Now I'm gonna divide by 5, So I have n equals 17 over 5, which should be the answer. So not too bad. So question 2. We'll do this one. So this is 2x equals 4. Pretty sure we did these problems before. So you have 1 or 2 options. I can look at this and say I need 2 times what? Well, 2, how many 2's I need times together to give me 4, right? Or we can do it this way that we've been doing, and try to get these base numbers the same. And then I can set the exponents equal to each other. So this is the trickiest part about this section. So you just kind of, as we go on, it may be easier to see. But I have 1 that's base 2, and that's the smallest we're going to get. I can't break 2 down anymore. So it must be this bigger number that I have to break down. And I know, and you could do the factorization to check, but I know 2 times 2 is 4, and 2 times 2 is the same as saying 2 squared. So I'm going to rewrite 4 as 2 squared. And I'm going to have this, now this 2x just stays the same. So now I've got it so my base numbers are the same. So they're both 2. So now I can just take these exponents and say x equals 2. And that's our answer. So sometimes you're going to have to mess around with it to get a correct base. So question 3 is going to be a good example of this. So I've got 4x minus 2 equals 8. to the 4x plus 3. Okay, my first step, I think this is going to be the best thing, is to break both these numbers down. So 4 is 2 times 2, and 8 is 2 times 4, and 4 can break down as 2 times 2. So right here, I've got 3 2's timed together. So that's saying 2 cubed. Right here, I've got two 2's timed together, so that's 2 squared. Okay, so now I'm going to rewrite 4 as 2 squared, and then I've got it, this 4x minus 2, all up there, and I'm going to rewrite the 8 as 2 cubed, and then the 4x plus 3. Okay, now I have to multiply these 2's in. So I'm going to have 2 times 4x is 8x. 2 times negative 2 is negative 4. So I got 2, 8 to the x minus 4. Then over here, I got to multiply the 3 in. So I've got 12x plus 9. Okay, now I've got it where my bases are the same. So now I'm just going to set these top parts equal to each other. So I'm just going to have 8x minus 4 equals 12x plus 9. And now I'm just solving this equation. So I'm going to add 4, and subtract 12x, subtract 12x. So I've got negative 4x is equal to 13, divide by negative 4, divide by negative 4, and I get x equals negative 13/4, which is one of those answers. I didn't say that, this is multiple choice. Okay, so same thing for question 4. Question 4 would be a good one just to try. Question 5 is what we're going to be doing next, because this is another one that you may see. So the big thing here is that with this, I don't want this fraction, because it's going to be hard to get 16 into a fraction. I have no idea how I'd go about doing that. So if you remember, 1/2, and this 2 is like saying that it's 2 to the first power, right, equals 2, because that's just saying it's 2 times this exponent. So I have 2 squared, that means 2 times 2. How many 2 cubed is 2 times 2 times 2. So this tells us the number of 2's I have. So when I just have 1, 2, it's like having a 1 exponent there. We usually just don't write it. So if you remember, if I have something on the bottom, to bring it to the top, I can do so, but I have to change the exponent to be negative. So I'm going to change that to -1, 2 to the -1. So I'm going to rewrite that. I've got 2 to the -1 n equals 16. So now I'm going to break the 16 down and see if I can get it to have a base of 2. So 16 is 2 times 8, which is 2 times 4, which is 2 times 2. And I've got 4 2's. So I can rewrite this as 2 to the 4th. And then we've got 2 to the -n. So now that I've got the same bases, those 2's, I can just take the top part. So I can say -n equals 4. And we don't like that negative over there, so we're going to divide by -1. Divide by -1, so I have n equals 4. Okay, so you may see some of those with the fractions. So if that's the case, just remember, if you had like 1/4 squared, I just bring it to the top. Okay, it just freaked out, but I think this is still going to work. Let's see. Okay, so what I was saying is if you see a fraction, like if I have 1 over 4 to the 2, I can just bring it up and say, this is the same as saying 4 to the negative 2. If you have 1 over just 4, what I can do is pretend like there's a 1 exponent here, and then say this is 4 to the negative 1. So I am not going to go over question 6, but you can work through it. If you would like, question 7 is kind of similar things. I don't know what question 8 is asking, so we're going to skip it. Okay, so question 9. Same thing, except now we're dealing with logs. So I have log with base of 2, 5x minus 1, and log base of 2, 2x plus 8. So this one's really easy because I've got log base 2, log base 2, which means that this stuff in the inside, I can just set equal to each other. So I got 5x minus 1 equals 2x plus 8. And now I just solve for this. So I'm going to add 1 over, and subtract 2. I would suggest not doing these in the same step, but I am going to. And you can just pause it so you're not, like, maybe the thing to do is when I get to this step right here, just pause it, solve for it, see if you get the same x. So I've got 3x equals 9. I divide by 3, and I have x equals 3 is the answer. So with these log ones, with the exponents one, there was sometimes we had to manipulate it, like in this last one where the bases weren't the same. With the log ones, I guess maybe we should see. I don't think you'll ever have to manipulate it. I think it will just be the same. Okay, so question 10. I guess this is maybe how you have to manipulate it, but I don't think this is as hard. So I've got 8 plus log 5 of x equals 12. And what I'm using here is what we've learned on the last section. Remember, when you have a log that it's equal to something, you use this. If I have x equals log b of y, then y equals b of x. So, sorry, let me try to go back. Okay, so first, to get it in this form right here, I can't have this added 8. I almost have it, but I have this weird 8. So I need to first bring this 8 over to the other side. So I just subtract by 8, subtract by 8. So I have log 5 of x equals 4. Okay, now this right here is in this form. So my x equals 4, my b equals 5, and my y equals x. So now I'm just going to rewrite it into this exponential form. So my y is x, my b is 5, and my x is 4. So that's my answer. They're having you do it by step by step. So the first box is going to be this answer. The second one is going to be this answer. And then your final box is going to be if you put 5 to the 4th in your calculator, you'll get some answer. I don't have my calculator on me, but that's 25 times 5 is 125 times 5. I don't know. So you'll get some answer, but just put it in your calculator. And that's what they want for the final box. So question 11 is the same thing. You're just given it in this form and you have to switch it to this form and then you'll solve. Question 12 is that same idea. Okay, we're going to go to question 13. So we've got 6 e to the x minus 9 equals 9. Okay, when you're dealing with this e, your first step is to get e by itself. So I want just like e to the x and everything else on the other side. So first things I'm going to add this 9, add this 9. So I'm going to have 18 equals 6 e to the x. Now I got to get rid of that 6. So I'm going to divide by 6 because it's being times by the e. Divide by 6. Now I have e to the x equals 3. Now to get rid of e to the x, I just have to take the natural log. And if I take the natural log of this side, I have to do it to the other side. So if you remember, the natural log makes it so the e goes away. So then I'm just left with x equals, okay, it's really struggling, but I'm just going to show you this last one. And I don't know how far I got in the last video before it cut out. I didn't realize it cut out. So let me just show you the work and I'll kind of explain it. Okay, so we started with this 6 e to the x minus 9 equals 9, this stuff in purple. And when I'm dealing with e, I want to get e by itself. That's going to be my first step. So I just added the 9 over. So I was left with 6 e to the x equals 18. And then I needed to get rid of this 6 right here. So I divide by 6 and I divide by 6. So then I was left with e to the x. Let me write this. So I was left with e to the x equals 3. To get rid of e, if you remember from last time, I take the natural log, this ln. And when I do it to one side, I've got to do it to the other side. So when I have the natural log and the e together like this, they cancel out. So you're just left with x. And then on this side, I'm left with the natural log of 3. And you can put this in your calculator to get some decimal. But that's what it's wanting when it has e to, when you have an e, and whether it's to the x or to the x squared, anything like that, when you've got this e and you're being asked to solve, your first step is to get e by itself. And then when you get e by itself, you can take the natural log and that gets rid of the e. And that is going to be the, well, not the rest of the problems, but the next few, and then the other ones are going back to the stuff we worked on at the beginning. So my computer's freaking out, so I'm going to end it. But we went through a few problems, and hopefully with the video, you're able to like pause and, come on, and like pause it if I'm going too fast. That way you can kind of really figure out what I'm doing, and then go back and watch examples while you work through another one. So hopefully this helps.